Okay, this is our second video on resistance. Last video we talked about Ohm's law briefly, the proportional relationship between V and I, and now we're just going to look at the idea of resistance in series and maybe resistance in parallel. So a series circuit would be very simply set up as follows. So we've got a power supply here, or a battery in this instance, which is providing potential difference. A series circuit is just like a TV series, one resistor after the other, and then connected in a circuit. Of course, the potential difference provided by this battery here is actually called EMF once it acts in a circuit. We're going to call this resistor 1 and this resistor 2. Okay, that's the quantities of the resistance as well for this question. What we're going to do is we're going to put a voltage meter across these two resistors. Okay, and we're going to call that V1. Okay, of course, voltage is always measured across the resistor, because it measures the potential drop or the potential difference drop across this, the energy used in pushing a charge from this point to this point. We're going to measure the voltage drop across here, or the potential difference across here as well, which is going to be V2. And then we're going to measure the voltage total across both of these. Of course, we know that the voltage in series, V1 plus V2, is actually equal to voltage total. And then also what we're going to put in here is I, an amp meter, and that's going to give us a measurement for I total. And of course, you know that I total is going to be constant all throughout the whole part of a series circuit. Let's write down series here in case you forget. It's a series circuit. It's going to be always going to be constant, because say for instance this is only allowing 4 amps of current through, and this is allowing 3 amps, then 3 amps is the most current that can flow through this circuit. Okay, the absolute maximum current that flow through this circuit. So when we look at this, right, our derivation is asking us to derive a relationship between resistors in series. So we know that voltage total is equal to V1 plus V2. Okay, we also know that V is equal to IR. So we're trying to get a relationship between resistors in series. So every place we have a V, we're going to put in IR. So V total is the same as saying I total by R total. Alright, and every place we have V1, we're going to put in the same. V1 is the same as saying I, and the current flowing through resistor 1 is I total, right? It's always that, times R1 plus I total for resistor 2, because the current is always constant, by R2. Because the current is constant throughout the whole system, we can cancel the currents, and that's going to leave us with the formula we're asked to derive. RT is equal to R1 plus R2. And you derived the relationship between resistors in series. You must include the diagram, and you must finish this answer always.